Last episode, you pushed your fine-tuned model to the hub and wrapped it in a Gradio space, a model card people can read, a demo box people can click. That's great for a human poking at it in a browser. But software doesn't click buttons. Your app, your backend, your phone, they all speak one language, an HTTP request. So today we take that exact same repo and put it behind a production endpoint, a real URL that any program on earth can hit and get an answer back in milliseconds. No notebook, no Python on the other side, just a request going out and JSON coming home. Here's the shift in mental model. Up to now, the model lived inside your process. You imported it, you held it in memory, you called a Python function. From this point on, the model lives somewhere else. It runs on a server you don't see, and you reach it the way you'd reach any web service. You send a message addressed to a URL, and a message comes back. The model became a phone number you can dial. Every call has two halves, and it helps to keep them separate in your head. The request is what you send, a method that says post, a path that names which model, a couple of headers, and a body. The actual text you want classified. The response is what comes back, a status code that tells you if it worked, and a body holding the prediction. Request out, response in. That round trip is the whole episode. 3 things make a request real. The URL points at your model's endpoint. It ends in your username and your model's name, so the server knows exactly which way it's to load. The authorization header carries your token, proving you're allowed to ask, and the JSON body carries the payload. For a text classifier, that's just inputs. Great product. URL says where, token says who, body says what. When the answer arrives, the first thing you read is not the prediction, it's the status code. 200 means okay, the server understood you and did the work. 401 means your token is wrong or missing. 422 means your body was malformed, usually the wrong shape of JSON. 503 means the endpoint is still warming up, a thing that happens on the very first call after it's been asleep. Always check the number before you trust the body. A 200 gives you the part you actually wanted, the parsed JSON. For a sentiment model, it comes back as a list with one object inside, a label like positive, and a score like 0.99. It's the same prediction your pipeline gave you in the very first episode, except now it crossed a network to get here. The format is identical because on the server, it really is the same pipeline running behind the scenes. And then there's latency, the single number production people stare at. It's the wall clock time from the moment your request leaves to the moment the response lands. A warm endpoint answering a short sentence comes back in tens of milliseconds, ours clocks 48. The very first request after a cold start is slower because the server has to load the weights into memory first. But once it's warm, it stays fast. Latency is the price your users feel. One more idea before the code. This endpoint is just a building block. It doesn't care who's calling. A web app, a mobile app, a cron job, another model in a bigger pipeline. They all send the same post and read the same JSON. That's the quiet power of putting a model behind HTTP. You wrote the prediction once, and now everything that speaks the web can use it in any language on any machine. Let's open the file. It's one script, 19 inference endpoint.py, and it fits on 2 pages. The first page builds the request and fires it. The second reads the response apart and prints it cleanly. We're using the Hugging Face Hub client, so we don't have to hand roll headers, but I'll show you exactly what it's doing under the hood, because the whole point today is to demystify the round trip. Up top, we import the client and grab the token from the environment. Never hardcode a token in a file you might share. We point at one model repo u sentiment, and we name the input we want to classify, the string great product. 3 constants, that's the whole setup. The token says who we are, the repo says which model, The text says what to ask. Now the request itself. We create an inference client pointed at our model and pass our token. Then we call text classification with our sentence. Behind that one line, the client is doing exactly what we drew. It builds a post to the model's URL, attaches the authorization header, serializes inputs, grade product and to the body, and waits. We wrap it in a try block because over a network things can fail. And a real client handles that it doesn't crash. This little block is the part most tutorials skip, reading the status. If the call raised, we catch it, print the failure, and stop. That's our 401 or 503 path. If it succeeded, we record the elapsed milliseconds with the timer we started just before the call. We print the status as 200, the latency, and a one-line preview of the result, so a glance at the terminal tells us it worked and how fast. Finally, we unpack the response. It comes back as a list of predictions. We take the top one, pull out its label and its score, and print them on their own line, positive at 0.99. That's the JSON in the figure, turned into two readable values. We've gone from a raw HTTP response to the one-factor caller actually wants. This text is positive and the model is sure. And that's serving. The same repo from last episode is now a live URL. You send a post, you read a status, you parse one JSON object, you act on it in 48 milliseconds. You've now seen every stage of the Hugging Face spine on its own. Find a model, load it, tokenize, run it, fine-tune, evaluate, quantize, ship, and serve. You've seen every stage in isolation. Next, we light the whole spine in one capstone.